Now that we understand the basics of inheritance in the realm of the Swift programming language, the next logical step to take within the object-oriented programming paradigm is to jump into something called polymorphism. Now, polymorphism can sometimes carry with it a shroud of mystery, but I assure you that it truly is not a very complicated topic. All polymorphism means is that I can override some sort of existing functionality that was predefined in one of the types or classes that I have ultimately inherited from somewhere in my inheritance chain. So for example, I could say that yes, a manager inherits from employees. So this manager type does contain a do work method and a job function property, as well as the first name and last name properties. Now, I would venture to say that in a normal work environment, a manager does have to do work, but the work that a manager does is probably going to be different from a typical employee. And so in this case, maybe a developer. So we can start to redefine what these operations in terms of functions and properties are within these classes to override them from previous levels of inheritance. So let's see how that works. So it's quite simple actually. So I could go into my manager class and actually just to prove a point. So I'm simply going to create a new instance of a manager. I'm going to say that manager is going to have a first name of Derek and a last name of Jensen. And at this point, I can now reference my manager object and I say do work. And as you can see here, it's going to say that I'm doing my work. But a manager's work is going to be different from an employee's work. So let's go ahead and redefine or override this do work method. So in this case, you're simply going to use the override keyword. And in this case, this is a function. We're overriding a function here. And this function is actually do work. So we're going to override do work. And we need to make sure that we specify everything the same as it is in the original implementation. So the signature or function type needs to be the same. It has to have the same name, the same inputs, and the same output. So at this point now I want to override this and I'm going to return I'm doing my manager work. So now that I've changed that, you can now see down below where I execute the do work method, I'm now seeing I'm doing my manager work. So as you can see, I am actually changing the existing implementation of a previously defined inherited type to do what it is that's necessary at that particular level. So that's kind of nice. But at the same time, I can simply create an employee. So we'll say var employee is equal to an employee. And in this case, it will be John Doe. And if I were to say that I want John Doe to do work, John Doe is simply going to say that I am doing my work. So now you have that separation that different levels in the inheritance chain are able to execute different predefined methods or functions in this case differently. But we're not limited to just functions here. We can override properties as well. And that's going to take the same form that we've just done. We say override, and this is actually going to be a property, and we're going to override, in this case, the job function property. So I'm going to paste this in here. I want to override var job function, but in this case, I don't want it to be the same as developer. Its job function is going to be manager. So at this point now, when I go into my manager, I can now specify or take a look at its job function. And as you can see here, we're getting a bit of an issue, and we have an ambiguous use of job function. The problem that we're running into here is that I can't override an existing property with another stored property. If I want to override it, then I actually have to specify it as a computed property. So the way that we do that, if you recall, is by creating getters and setters. So in this case, I'm simply going to override this with a computed property. And when I'm doing this, once again, if you recall, I have to create a getter with the get keyword and a setter with the set keyword. And we're going to say that this is going to have a variable name of new value. And we already know that this is going to be of string type, so I don't have to specify any types or anything there. And if you don't recall the ins and outs of computed properties and getters and setters, you can go back and take a look at the properties lesson earlier in the course. So at this point, I could do any sort of complicated logic that I want here, but there's really not a whole lot extra that I really want to do. I actually just want to return that the job function is now going to be manager, so that's going to be fine. And then let's say I want to set this, so somebody wants to actually set this job function to something else. So how am I going to do that? Well, there's an interesting little trick that you can use here. If I am in my manager class and I want to access some sort of functionality that is in the class that it's inheriting from, you can refer to that as the super class. So if I wanted to refer to the value that's stored in the super class level, I could say super dot, and in this case, it knows that the super of this particular class is employee, which has a do work, first name, last name, and job function. So I want to set the job function equal to whatever new value is being passed in. Well, that's good, but the problem now becomes if I set the job function at the manager level, it's going to change what's been defined at the employee level, but we're just returning this hard-coded value here for its job function. So if I were to look at this now, you'll see that it's a manager, but if I were to specify that its job function is equal to sleep, not to imply that managers sleep, now if I were to access job function, again, I would expect it to be manager, but in this case, it is sleep. So the problem here is that I'm only returning a hard-coded value, so to retrieve the value that's in the super class, once again, I can simply say I want to return super.job function. And once I do that, you can see that I can now set my job function property to be sleep, and then when I access it later on, it's going to be sleep. So as you can see here now, we have the basics of the ability to implement polymorphism within our inheritance chain amongst the custom types that we're creating through classes and be able to override functionality at certain levels that are necessary and get access to the inherited types or the super types throughout our inheritance chain. So these are some very nice tricks to be able to have in your tool belt when you're doing object-oriented programming